Good afternoon, Algebra 2. Today we're going to talk about logarithms to bases other than 10. So we already learned about our common logs, which are logs that have a base of 10. And obviously those are going to be the most common, but that doesn't mean that's the only kind of logs that we have. So our log of x to the base b, it works the same exact way, except this b is no longer going to be 10. So log of base b of x equals y. It works the same way. If we write it in an exponential form, we take the y, put it on the exponent of b, and we get x out. So x goes out this way, which is exactly what this says here. Take y, put it on an exponent of b, and we get x out. Okay, so it's the same process, it's just b is no longer 10. So we're not working with bases of 10. So in general, the graph of a log function with base b is the inverse of the exponential function with base b, which we already saw with our common logs of log base 10 of x was the inverse of 10 to the x power. So these were inverses. So it's going to be kind of the same thing, but let's just say we have maybe log base 7 or something of x. Then it would be an inverse of 7 to the x power. Okay? So we have to have 7 here still, but those would be inverses of each other as well. Okay, so let's take a look at our first example here. It says graph f of x equals log base 2 of x. And f of x is at 2 to the x power on the same coordinate plane. So let's go ahead, I'll get a different color for my exponential. Do this blue, that's pretty. Okay, and let's go ahead and grab our calculators so that we can actually graph these. The easiest way to get an XY chart is through this guy. So we go to our y equals screen, which is this guy right here, and we say, all right, we need to graph these equations. So log base 2 of x. Now log base 2 of x. Well, we have a log button, but if you remember correctly, we cannot change the base on this log button. So its base is actually 10. So we can't actually use this button because we want log base 2, and that's log base 10. So we're actually not going to be able to get order of pairs for this guy. But that's okay, because we can get some for this guy, and I'll show you what we're going to do here. So we have 2 to the x power. Let's go ahead and graph that. You might be in the same window, you might not be, so your picture might look like this. Okay, good enough. We really care about our table of values, so we're going to go here, and let's see what'll fit. So let's go to the left here, or up rather. And okay, so we got a bunch of values here. Let's do negative 1.5. So this is our blue color. We still have it. Okay, so negative 1.5 is going to be right about here. And then our next one is 0, 1. I hope you're graphing along with me and also following in your calculator. You'll have to do this tomorrow. And 1, 2. So 1 and then up 2. And then 2, 4. 2 and then 4. Actually, we could have done this one easily by hand. We're just taking 2 to a power, so 2 to the next one would be to the third power, which would be 8. So 3, 8 will be our next point here. Okay, and I think that's pretty darn good, so let's go ahead and sketch this in. Remember, we do not cross that x-axis, but we come dangerously close. Hopefully you hit all your points, and then our arrow is going to go off that way. Okay, so there is our exponential function. And we, like I said, we can't put our log function into our calculator. We don't know how to do that yet. So, but we do know that these, since you have a log base 2 and you have an a base of 2 here with an exponential, these are going to be inverses of each other. So we know, so inverses, we know that inverses all reflect in the line y equals x, and that will always happen for us. So let's go ahead. And I'm going to grab just like a black color to draw in that line. Remember, it basically goes corner to corner here. I'm going to draw it in as best as I can. There we go. So that's our line y equals x. So y equals x. And all we have to do to get our new picture here is we got to reflect over that line. So let's go ahead and grab the red color. And essentially to reflect over, you just go to the line and exactly that distance away. So this point's going to be right here. And right here, we're going to be right here. Notice my line's a little crooked. Maybe you grabbed a ruler and you could do yours a little bit more accurately. This one's going to be right here. You could also, if you wanted to be super accurate, whoops, I did this one wrong. Hang on a second. That's why we use erasable ink, so we can always get rid of it if we need to. Or you guys should be using pencil, I suppose. You could always, this would be, no, it would be right here. There we go. Told you my line was a little crooked. You can always figure out what these points are and flip them. So this point right here is 2, 4. So my other one's going to be 4, 2. And I could say, all right, there you go. And this one was 3, 8. So it's going to be 8 and then 3. So there you have it. Okay. So that'll be maybe a little easier for us at this point. So, and then we go ahead and draw this in, remembering not to hit our y-axis here. Hopefully you've caught all your points. And that one's going to go out that way and down this way. So this is our log function. So f of x equals log base 2 of x. And then the other guy, sorry, let me grab my other color here. Should have thought of this earlier, is f of x equals 2 to the x power. So if you're asked to graph them both, and you can only do one in your calculator, you could just say, okay, well, they're inverses, so I know they're going to reflect over this line, or their ordered pairs are going to be exactly opposite of what they were. So you could do it that way too. You don't need to use the technology every time. So notice, let's do the domain and the range for this guy. So the domain is, we squish it to the x. Remember, this never touches 0. So we start at 0, but we're not touching it, and we go to positive infinity. And our range for this guy, we squish it then to the y for the range. This is going to go down to negative infinity, and this will go up to positive infinity. So negative infinity to infinity. So without even looking at the graph, we could very easily determine what the domain and range for our exponential function are, because all we have to do is flip-flop these. So our range becomes what our domain was, and our domain becomes what our range was. So I'm going to go ahead and write small, I guess, in here. Domain now is negative infinity to infinity. And our range is that 0 to positive infinity, which if you look at our graph, that would be the case, because if we squished it to the x, we'd go from negative infinity to positive infinity. If we squished it to the y, well, this guy, remember, can't touch 0, so we don't touch 0, so non-inclusive, and we go up into infinity, okay, which should be the case here. Okay. Notice we have a y-intercept of 1 here, and we have an x-intercept of 1 here. Those are going to be exactly opposite. And we have an asymptote for this graph, which is your x-axis. We always draw asymptotes in with a dotted line. And then an asymptote for the red graph, sorry, I'm just going to do it in blue here, but our asymptote for this red graph is the y-axis. Okay? So a bunch of different properties. These still apply to logs with other bases rather than 10. Okay, so example 2 says evaluate the following. So we have log base 2 of 16, and they want to know what that is. So right now it equals some unknown quantity we'll call x. And these work just like all of our other ones, so we can take this and put it as an exponent on 2. So we have 2 to the x power, and then pop the 16 to the outside, so equals 16. Okay? So then you want to ask yourself, well, 2 to what power gives me 16? Well, we could rewrite that as 2 to the x equals, now 2, let's count them, 2 times 2 is 4, times another 2 is 16. Nope, back that up. 2 times 2 is 4, then times another 2 is 8, and then times another 2 is 16, so I counted 4 2's. Sorry for messing that one up on you. Of course, that would be me to do that. So 2 to the 4th power is equivalent to 16, so all I did was replace 2 to the 4th power for 16. And then remember, if our bases are the same, we can get rid of them. And we could just say very easily that our exponents are equal, so x here is going to be 4. Okay? So log base 2 of 16 is going to be 4. Okay? If you wanted to check these, you could grab your calculator and, oh, wait, we don't know how to put logs of other bases into our calculator, so wah, wah. Looks like you're stuck doing these by hand. Oh well, that's okay. I trust you. I really do think the answer is 4, so that's what we'll put down. Okay, let's take a look at another example here. Again, rewrite this in exponential form. So we say equals what? We don't know. So x then goes on to the 6. So we have 6 to what power? Gives me, whoops, radical 6. Okay. Now radical 6, again, we don't know what power that is. So I would go ahead and say 6 to the x power equals 6 to the, well, instead of saying square root, we could say that is to the 1/2 power. So maybe we do know what power that is. So the bases are the same already, so we don't have to think about that. So all we say is okie dokie, our exponents are equal, so x is 1/2. So therefore the log base 6 of the square root of 6, which is what they're originally asking me, what the heck does that equal? we know that equals 1/2. There we go. Alrighty, last one. Why don't you guys try this one and bring me your answers tomorrow? I'll leave that one for you. You know what? No, I think I have some at the end of the slide here. So we'll do this one together so you can get a little bit more practice, and then you'll be on your own later. So we take our equals x, we put the x on for the exponent, so 5 to the x power equals the 1/5 gets bumped outside, equals the 1/5. All right, yikes, 5 to the x. Now, ooh, remember, if you have 5 downstairs, that just means, well, 5 to the first is 5, right? That means I could rewrite this as 5 to the x power equals 5 to the negative first power, because we know 5 to the negative first, all that does is put it downstairs, and it becomes 5 to the first, which would give us our 1/5 that we needed. So we know if they're downstairs, so we can make a note here if we want, downstairs equals negative exponent. Okay, because it'll always be that way. You say, oh, it's downstairs, that must mean negatives are involved somewhere. So it does, and it's to the negative first power. Okay, so then again, look, our bases are already the same, so we say x equals -1. They didn't care about the x, they wanted log base 5 of 1/5, so we'll rewrite it as log base 5 of 1/5 is -1. So there's our answer. And notice none of these were decimals that repeated, so we used exactly equal to and not approximately equal to here. Okay, we have a couple more examples, so I'll see you in the next video for those.